Hi everyone. Today is our first lesson of Chapter 8, and it's called the geometric mean. And so after this lesson, you will be able to find the geometric mean and solve problems involving right triangles. So let's take a look at our one vocabulary term. The geometric mean, again, is just the positive square root of the product of two numbers. So if you look at this key concept, the first thing that we can do is we take a look at a proportion that we've created. And you could use cross products. X squared is equal to AB. So therefore, we know that in order to solve for this for x, we're going to take the square root of both sides. And so basically, the geometric mean says whatever this variable is that's in common between your two proportions, that's going to be equal to the square root of the other cross product. And now for theorem 8.1, I thought I had that. Let me look real quick. I thought I had that on the next slide. Yep. So let's take a look at this. Theorem 8.1 talks about the altitudes of triangles. And if we can take a look at a bigger triangle, and inside we have these two littler triangles. So if the altitude is drawn to the hypotenuse of a right triangle, then the two little triangles are similar to the original. So all three triangles, the original big one and the two that are inside, they are all similar. And then when we get to example 3, we're going to use these two theorems, 8.2 and 8.3, and they just talk about geometric means, and they use the idea of corresponding parts, and we set up proportions, and we can use those geometric means both with the altitude and the leg theorem to come up with different ratios. So let's take a look at our examples. The first thing that we're going to do is find the geometric mean between 12 and 15. So as the definition says, we know that the value of x, or the geometric mean, is equal to the square root of the product of two numbers. And so I'm just going to take and substitute my 12 and 15 in, and I multiply them to get 180. Which gives me the square root of 36 times 5. So we can either say that this is 5, not 5 square root of 6, 6 square root of 5, or we can say that this is approximately 13.4. Again, the geometric mean just says take the square root of the product of two numbers. So we're going to identify the three similar triangles. This goes back to theorem 8.1. So we've got three triangles here. So what I'm going to do is kind of take them all apart. And the first triangle that we have is KML. And I'm going to take that original triangle and I'm just going to rotate it so that my right angle is here on the left-hand side. So M is my right angle. Here's L. And there's K. So that's the big one. And theorem 8.1 says if you draw an altitude inside, the two little triangles are similar to the original big one. So I'm going to focus on this one that I've outlined in blue. Again, I'm going to rotate it so the right angle matches. My right angle in this one is P, so here's my P, angle P. And as I look at this, then I see that K is here and M is there. Okay, and then there's a third triangle, so I'll outline that third triangle in green. And that third triangle, again, I'm just going to orient it so they're all facing the same way. Again, P is a right angle, it's right here. And here's M, and here's L. Okay, so what we can say by theorem 8.1, triangle KML is similar to triangle KPM and is similar to triangle MPL. And so what we can do, not only can we find similar triangles, but then we can use that idea to write proportions to help us solve the different problems. And so this particular slide, after I talk for a little bit, you might want to hit pause and kind of reread it a couple of times, but this particular slide takes a look at a triangle very similar to what we just had on the previous page, this one right here, and it breaks it down into the three parts, and it talks about the different ratios that you can come up with that are similar. So we're going to use that idea in our next example, along with theorems 8.2 and 8.3. So in this one, we have to find the values of x, y, and z. I'm going to start with finding x. So in here, I can say, so for x, I can say that 12 is equal to the square root of 9 times x. And why can I do that? That's because of theorem 8.2, which is the geometric mean altitude theorem. So I'm going to make this ratio, where we learn from that we can make this problem. So how do we get rid of that square root symbol? We're going to square both sides. So I get 144 is equal to 9 times x. And all we have to do is divide by 9, and so we get 16 is equal to x. So that's our first one. So I know that x is equal to 16. Now, I also then need to remember that this whole length of this side then is 16 plus 9, which is 25, because we're going to use that to help us figure out the value of both y and z. So for y and z, we're going to use the geometric mean leg theorem. Again, what I would suggest that you do is go back and forth, or even take a look on page 533. Have your book open to 533 as you do this example. And you can have your book open and this example as we go, and you can see where I'm coming up with the different ratios or how to solve the problems. So now I'm going to talk about finding y. Okay, y is over here. So I'm going to set up my proportion as 25 over y is equal to y over 16. And again, look at the theorem to show you, or even the picture on the bottom of 532. From here, we know from the geometric mean, we can say that y is equal to the square root of 25 times 16. And so we get y is equal to the square root of 400. And then to get rid of the square root symbol, we can square both sides, so we get y is equal to 20. So far we have x is equal to 16 and y, oops, that's not y is equal to 20. And now what's left is to figure out the value of z. So we're going to do the same thing. And I was going to switch to a different slide, but I think I'll just keep everything here and talk about for solving for z. Just like before, we're going to use that geometric mean leg theorem. And so my ratio here is going to be 25, or my proportion, over z is equal to z over 9. And the geometric mean theorem says I can take 25 times 9, find its square root, and that'll give me the value of z. So 25 times 9 is 225. And the square root of 25 is 15, or excuse me, the square root of 225 is 15. Again, just one more piece of reminder, I would say look back at 533 for theorems 8.2 and 8.3. Those particular theorems are exactly what I used to solve this problem. Again, I used theorem 8.3 to help set up the proportion to find z. I also used theorem 8.3 to set up the proportion for y. And I used theorem 8.2 to set up the proportion for x. So there you have it. The geometric mean, and then using that information to help you find missing values of right triangles.